Researchers have mapped carbon emissions across an entire city, down to the level of individual buildings, according to research published in ACS's journal, Environmental Science and Technology. This is Breakthrough Science, ACS Journals in the News.
Initially, Hestia in many ways was born out of a previous project called Vulcan, which attempted to quantify all fossil fuel CO2 emissions for the entire United States down to scales of about an individual county. And of course, carbon dioxide is the most important anthropogenic greenhouse gas in the Earth's atmosphere. And the idea was to quantify those emissions down to the scale of individual buildings and road segments, and that's what Hestia attempts to do. Our goal was to capture every single molecule of fossil fuel CO2 leaving the surface and quantify it. And so I think we've accomplished that, and we've done it in such a way that we can do it not only for the city that we chose, in this case Indianapolis, but for any U.S. city, given the common data structures that exist across the United States. We've begun work in Los Angeles, and by Los Angeles I mean the entire LA basin, which really touches 5 different counties in the South Coast, Southern California area. And we've also done preliminary work in the city of Phoenix, or actually the entire valley here, which also includes a number of different cities, Phoenix being the largest. And we'll begin working on Salt Lake City in about the next 3 months. I'd say the other thing that came out that was a bit surprising was that we're able to actually capture the time fidelity of the city as people wake up in their homes, turn on their heaters, go about their morning business, then get in their cars, move to workplaces, show up at work, and have the commercial sector and industrial sector light up. So we're able to see the flow of people as they move around the city over a 24-hour cycle. I think it's going to go in 2 different places. On the scientific side, I think this work will converge with work that is using satellites, aircraft, and instrumentation on the ground that measures ambient CO2 in the atmosphere. And the idea is to connect what we emit from the surface with what's being measured in the atmosphere. And the idea then is to make those 2 systems conform with one another. And that's been referred to as a carbon monitoring system. And this is the type of thing that many governments and agencies around the world would like to see in order to enable an international treaty on climate change, which has been a difficult thing to achieve. I think it's exciting both because it's technically challenging and incredibly relevant. I like both doing technically challenging work, but stuff that matters to people. And I think this work really matters to people in their day-to-day lives. And it also, I think, is part of the solution to a very, very long-standing and difficult problem.